So chapter 2, all about graphs, and now we're going to talk about circles in section 2.4. So objective 1 is going to be writing the standard form of the equation of a circle. And you're going to see we're going to need the completing the square that we've been doing. Number 2 objective is going to be to graph a circle. So writing its equation, then graphing it, and then work with the general form of the equation of a circle. So notice we're talking about two different forms, a standard form and the general form. Okay, so objectives 1 and 2 we're going to do together, talking about writing the standard form and doing the graph. So we need a definition for a circle. A circle is actually a set of points, just like we've been talking about, that all the graphs we've been looking at are actually sets of points in the xy plane. And they're a fixed distance we call r from a fixed point that we label hk. So the fixed distance r is called the radius, and the fixed point is the hk is called the center of the circle. So then we have a picture here of, well, what does that look like? We have the point hk that's at the center, then every point on the circle is a distance r from that center. So the distance between the points x, y on the circle, no matter where it is, and hk will always be r. So using the distance formula, we know that the distance from xy to hk has to be r. So let's see if we do y minus k quantity squared plus x minus h quantity squared. Remember we said the order of these doesn't matter. The square root of that will equal r. Well, if I square both sides, I'm going to have y minus k squared plus x minus h squared equals r squared. And usually the x term would be first. So x minus h squared times y minus k squared equals r squared. So sure enough, we get the standard form of an equation of a circle with radius r and center hk. Looks like x minus h quantity squared plus y minus k quantity squared equals r. So I'd encourage you not to memorize this formula, but to think about where it comes from, that the distance from any point xy on the circle to the center is always r. So the standard form of an equation of a circle of radius r with center at the origin, so this would be when h equals k equals 0. So then we get a simpler equation. We just get x squared plus y squared equals r squared. Sorry, I forgot the squared there. And if the radius happens to be 1, the circle whose center is at the origin is called the unit circle and has the equation x squared plus y squared equals 1. So that's a special circle that comes up a lot in other applications. Okay, so let's write the standard form of the equation of a circle of radius r and center hk. So we'd have x minus 2 quantity squared plus y minus negative 3 quantity squared equals 4 squared. So that would look like x minus 2 squared plus y plus 3 squared so x minus 2 squared plus y plus 3 squared equals 16. Okay, so then we graph the circle by going to the point 2, negative 3, and don't forget to label the axes. and then it's 4 to the edges of the circle any direction we go. So 4, 4, 4, 4. So I do those 4 points as kind of guides and then draw a nice, smooth, symmetric circle. Okay, and then we just talked about intercepts in the previous section. So that's something important that we want to know about circles. So to find x-intercepts, we set y equals 0, and to find y-intercepts, set x equal to 0. So the x-intercepts, let's see, we set y equal to 0. So for this circle that we had, we're going to say x minus 2 quantity squared plus 0 plus 3 quantity squared equals 16. So x minus 2 quantity squared plus 9 equals 16. So that leaves me 7 on the right. So we can use the square root property and say x minus 2 equals plus or minus the square root of 7. So x equals 2 plus or minus root 7. So those would be the x-intercepts for this circle. Does that seem reasonable? 2 plus root 7 and 2 minus root 7. Yeah, that looks reasonable. Then the y-intercepts we would find by setting x equals 0. So we'd have 0 minus 2 quantity squared plus y plus 3 quantity squared equals 16. So 4 plus y plus 3 squared equals 16. Y plus 3 quantity squared equals 12. So y plus 3 equals plus or minus the square root of 12, but we need to write that as plus or minus 2 root 3 because we've got to simplify radicals. So y equals negative 3 plus or minus 2 root 3. So that's how we find the intercepts for the circle. Okay, so when its graph is a circle, the equation x squared plus y squared plus ax plus by plus c equals 0 is the general form of the equation of a circle. So if we squared out the previous example, and we did the x minus 2 quantity squared plus the y plus 3 quantity squared equals 16. We'd get x squared minus 4x plus 4 plus y squared plus 6x plus 9 equals 16. So we'd have x squared plus y squared, so y, sorry, minus 4x plus 6y minus 11 equals 0, and then it would be in this general form. So if the equation of the circle is in general form, we are going to have to use the method of complete the square to put the equation back in standard form so we can identify the center and the radius and graph it. So this example, we need to find the center and the radius and graph the circle, and let's do that one together in class. And then also this harder example.